Hello, everybody. Thank you very much for joining me here today. This is Paul Taubman with 9.connects, and you are in the right place if you are here today for our webinar on salvaging and restoring of a functional library. So we're going to get started over here. Some housekeeping notes. Feel free to use the question panel that you have with your GoToWebinar to ask questions. Along with me here today behind the scenes is Tom Cassidy, who's done webinars with us here in the past. Tom and I have been working very closely to develop our library services here at 9.connects. His knowledge of this is just as good as mine, and he'll be able to answer your questions as we're going along. Of course, the one thing I'd always ask you to do is please be specific as possible so that you don't have to keep going back and forth to try to clarify things. And we will stay on for questions, though. I'm going to forewarn you right now that this is everything I'm going to present to you. There's a lot to present, and we will probably go towards the end of the hour, but we'll definitely stay on for questions because we know it's a very important topic for many of you. And so with that, let's start off with a polling question. I'd like to know why you're here today. So are you curious, looking to expand your knowledge, or you need to address your libraries? Okay, very good. So hopefully you guys can see the results of that. So 11% of you are just curious, which is great. Always good to know what's out there in terms of library stuff, especially since it does impact design quite a bit. And then a lot of you are just looking to expand your knowledge, and trust me, you will be drinking from the fire hose today. And some of you do need to address your library, and I think you're going to be in the right place because after you're done with this, it's going to give you a lot to think about. And then one other question I do have for you for polling, so we'll start that one here, is what's the status of your company library? We're kind of curious to know here. So do you don't have one, or have one that's in rough shape, but you have one and content or living with it, or you have one but you're looking to migrate, or the company is going to have you migrate to a new system? And so about literally half of you are content with it, which is really great. I'm glad to hear that because obviously when we have customers call us up, they're not content with it, but we don't expect people to call us up to say that they're happy with it. So it's a good point for us to know that half of you are very happy with it. Those who don't have one, maybe it's because you don't necessarily need one. You're just here again out of more curiosity than anything else. But those who don't have one and are looking to create one, hopefully you'll get some great information out of this today. And there are always those who are looking to migrate. So again, hopefully what we're going to talk about today is going to give you some ideas about how you're going to have to approach that. And for those, of course, and a lot of you do have a rough one that's in shape, well, that's just par for the course, right? And you probably know better than I do as to why it's in the condition that it's in. And again, I hope that you'll get some information out of this today to possibly get it into a better condition. So with that being said, let me jump into my objectives. Number one, we want to define something called the library structure. This is really, really important. I think all too often when people try to tackle their libraries, they just dive in and they try to fix something, and it just ends in frustration. And it's a lot of times because they didn't even define library structure to begin with. Secondly is the structural implementation. Once you've got it defined, the structural implementation goes relatively smoothly. The next one, we're going to spend a bit of time on this here today, is library restoration. This is where really the rubber meets the road, where you get to really have to dig in there and clean up the library. And unfortunately, there's not a whole lot of automation to that, as you'll see as we go along here. And then lastly, your component migration, because most of the time we do a library restoration, we don't do it in the product itself. We actually do it externally so that we can bring it into the product. And you'll see why as we go along here today. So those are my objectives. Let's jump on into library definition. So library definition, what do we mean by that? Well, let's define what we mean by library definition. It's really the structures. What do we mean by that? The database structure. What container are you going to use to hold your parts in? Your components. How are you going to formulate your components? What do you expect in terms of categories for your components? And the parameters for each one of those categories. Also graphical, symbols and footprints. So that's where we're going to kind of explore here in the definition and in this definition topic. Okay, so the first question that you may want to ask yourself from the very start is, what software are you going to use? So when we're putting this together, of course, most of the stuff that we do here at 9.connects is to assist customers with Altium 365 and Concord Pro. But quite honestly, there's a ton of software products out there for you to use in terms of putting together a library. So what are they? Well, there's Altium Designer, That's the default library anyways. And in some companies, especially if you have a dedicated librarian, what Altium already provides out of the box will work for you. But again, you got to have somebody who's dedicated to that, and most of the time you don't. So as a result, you're trying to look for something that can take some of that burden off of your shoulders. So what are the other products out there? Well, there's Excel. Now, Excel is not the best product for it, but a lot of people like to use it, and we use it all the time as a temporary database. And that's what you're going to see here today, because it works really well in getting us to the ultimate goal of getting it into a container. But things like Access or even SQL, these are products that you can certainly use, and Altium can interface with them. But they do put a lot of burden on you, because not only are you trying to maintain the components, you're also trying to maintain the actual database itself. Now it's up to you to create the tables. Now it's up to you to maintain the parameters. Now it's up to you to create the forms that people use so that the data entry is done properly. And it's going to be up to you to clean it up when they don't do it properly. So there are other products out there like ours, L9, and there's even products like Randy Clemens. There's this one called Parts that he has, which I like. It's simple and very effective. And these products over here are databases, but we've taken the liberty to basically put it in such a format that it works specifically for components. These are for component libraries. So yes, there's a database behind them, but the interface for it was designed for components. Another way you could go, and a lot of people are probably looking into this, Concord Pro or Altium 365. We've talked a lot about these. Now you're starting to get into that realm of what they call the PLM systems. So this is not just about a library. These are about files and the maintenance and the management of those files. So yes, it is definitely libraries, and that's where our focus is. But there's also templates, and there's also projects as well. So you've got a lot of different files that you're trying to maintain here, and you're starting to get into the concepts of revision control as well. And then sometimes you get a product that's kind of outside of it, but it's still in the engineering domain. So SolidWorks PDM, for example, is a really useful tool, because not only does it work well for the mechanical folks, specifically for SolidWorks, but it also works very well for other products like Altium Designer, or those that are of the engineering nature. And then lastly, you start getting into really the corporate-wide things like Windchill or Oracle and Arena. And this is where maybe there's a mandate that's being brought down for the whole company to start integrate everything together. And this is not necessarily a bad thing, because if you sometimes get purchasing involved, then you can really get that library really tight. We've always advocated here at 9.connect that the best library that you can have is one that is actually integrated in with the purchasing system, because upon creating that part, you're already in sync with the purchasing system. One of the fundamental flaws with all these libraries, unless you do have it integrated, is that there's always a lag, right? You create your library part, and then at some point it makes it into the purchasing system. And at that point, it doesn't always get fed back. Your information doesn't always get fed back into the library. So that lag does cause a lot of issues. To me, it's a fundamental issue with libraries. But nevertheless, you do need to have a container. None of these are autonomous, which is unfortunate. But maybe someday that will be a reality. But it doesn't matter which one of these you pick. They all have their advantages and disadvantages, and you're going to need an administrator for it. So just be aware of that. So that's the first thing. The second thing is, what is your workflow? And we can break down the workflow into really two areas. The first one, let's talk about revision control. And to me, revision control is really a double-edged sword. I like it and I don't like it. And unfortunately, once you start getting into the Altium products, the professional, like Concord Pro or 365 Pro, and any of the PLM systems, you have revision control. It's just the fundamental nature of these type of systems. So they're in all PLMs and PDMs as well. And then why do you even have it to begin with? Because what do these things really provide? They provide you a where used feature. That's one of the powerful features of that, saying like, well, where did we use it? Because if this part goes obsolete, we want to go through all the projects and find out where they are so we can properly make those changes. So you do have to have some level of revision control for that. Unfortunately, there's just no stopping. It's all recorded. So if you start making, let's say you import all this stuff into something like Concord Pro L3 365, and you start making these changes, what you're doing is you're constantly recording. You're not stopping on anything. You're adding more and more and more to it. So you're bloating the database, and you will see some noticeable effects on the response time. And you really are forced, you force a rev upon save. So if you think about it, especially in Altium products, if you're working on a project, thinking about this the other day, I thought it was kind of fascinating. So in Concord Pro Altium 365, if you if you do save it, you bump the rev. However, if you're working on a project, you actually have two revision control systems that are in play. One of them is the Git, which is off to the side, and as you're going along and working on your project, then you make the decision to push it into the revision system. And then when you're ready to do the formal release, then you actually push it into Conqueror Pro or Altium 65. So they give you the option to do a bunch of saves before you ultimately push it into one of those two systems here. That's not true with libraries. The minute you save it, you force a rev upon it. So, and again, this goes back to what I was saying earlier, that a lot of times when we do our work here, in fact, almost all the time when we do the work here at 9.connects, we always do it external because we don't want to keep on forcing revs on components once we've migrated them into someone's system. So that's the double-edged sword with revision control type of libraries. Another one here is Lifecycle. Lifecycle to me is an interesting creature because I think we all want it, but there's implications to it. So what I did was I pulled this one out. This is an example that comes with Conqueror Pro or Altium 365, but you could also do the same thing in a database library. Instead of calling it Lifecycle, you could have a parameter that is called status. And in Lifecycle is a really tricky parameter. I think it causes a lot of problems because what have we always said in the past here at 9.connects? When we've done our webinars, we said, like, look, when you create a library, avoid dynamic parameters. And what are dynamic parameters? They're ones that change over time, and sometimes they change very rapidly, like price, lead times, stock numbers. Those are things you don't want to keep. In fact, if you think about it, in Altium Designer, the whole idea of a part choice is to take that burden off of you. That's why you put a part choice in there, because you can look at the part choice and it'll update it in real time. And one of the other things it does kind of provide to you, by the way, part choice is the status, right? It'll let you know whether or not it's got parts or not. It doesn't necessarily give you always the lifecycle status though. But here's the deal with the lifecycle status. You can get really fancy with it, but there's implications to it. And it's not just whether or not it's obsolete or not, by the way. So if you do create a lifecycle status, either by using what's built into the Altium products or you do it in your own database, you're going to have to come up with different states. And here's a state, a series of states that Altium came up with, which I thought was pretty cool. So let's go through this and then let's understand it a little bit better. So by default, when you create a new part in one of the Altium products, you'll start in draft mode. And this is true no matter how you set up your life cycle. But in this particular life cycle, if you decide to go with it, then you'll move it to the next state once someone checks a symbol. You'll move it again once the footprint is checked. And then from there, you'll put it into a prototype stage saying like, well, we don't have it in product, but we're going to put it in this stage here. And then once it's been proven out and you already put it into a product, then you move it to production and it'll stay in production until it goes obsolete. So this looks cool, this looks great, but what's the problem with it? The answer is, who is going to maintain this? Because this is just one life cycle for one part. What if you got 1,000 parts? And unless there's a specific mandate that we have, somebody has in order to go through these parts to get them through the states that they have, no one's going to do it. Like if you said like, hey, just if you see a part in there, check it out and bump the status on it. Well, I've got my parts and I've got my work and I've got to do my things here, and I'm probably not going to be looking at other people's stuff just because they don't have time. And I wouldn't expect other people to look at my stuff too for the very same reason. So something like this is noble, but it's really not effective unless somebody really owns this. And in fact, what we've been trying to do is encourage customers who, when we talk to them about life cycles, is not to go through something this fancy, but it's going to start off in draft. If someone thinks it's worthy of production, bump it to production, and then once it's been declared as end of life, then move it into obsolete. But even then, going from production to obsolete, that information doesn't always flow very well, because when are you going to find that out? Well, unless you happen to find out when you're putting together a bill of materials, or the purchasers find out when they're putting it together, and they do actually feed that back, if they actually feed it back to the design team, which doesn't always happen. So there's a lot of lag that goes on here, and there's a lot of work that goes on here. So if you are going to try to do something with lifecycle, either because it's built into the product or you're trying to add it to your database, just be aware to not make this so complex that no one's really going to mess with it. And it's just, everything's going to be in the draft state. And that's what I see all the time in my experiences. Okay, so workflow, revision, work, and the actual life cycles as well. So the next thing you're going to want to deal with are the part categories and subcategories. So here's a list of it. And, a lot of things like capacitors, resistors, inductors, and those type, that you're going to have a folder for it. But things can get interesting in other areas, and this is where you want to talk to your colleagues as to how many of these folders that you want. And more is not necessarily better. And the reason more is not necessarily better because in certain tools, for every single folder you create, you're also going to have to create a template for that folder as well. And that's just going to add a lot more effort on your part to do that. And in some companies, for example, integrated circuits. Well, if you're using like 100 or less integrated circuits, it may just be easier for you to put them in one folder and then just make sure the descriptions are done appropriately. Or if you have a lot of integrated circuits, you really need to have their specific parameters for each one being shown. And like, for example, whatever's for amplifiers may not necessarily be true for clocks and timing, then you may want to break these things out. It's going to be up to you. Another area that I always thought was kind of messy is when you start getting to miscellaneous. You want to determine why you have a miscellaneous category and can it be better described. So some people might say, well, I've got fiducials and I've got test points in miscellaneous. Well, those actually to me sound like they're embedded rather than necessarily miscellaneous. So be careful of categories like this because they're abused, or things like mechanical. What are you really defining in mechanical? Are these things like screws, nuts, washers, spacers? Is that what you're defining as? Is that not really hardware? And so those are the kind of things that you're going to have to battle out. And you may say, no, that's considered to be mechanical, and that's perfectly fine. But that's what you want to do, is look through this and work with your colleagues on this, because they're going to obviously have their opinions about this too. But again, make sure you don't go crazy with this list, because ultimately the next stage here is the parameters. And you're going to have to set up parameters for each and every single one of these categories or subcategories. Okay, so let's talk about parameters. So there are common parameters versus category specific. Common parameters would be company part number, manufacturer's name, manufacturer's part number, package type, status, if you want to go down that route, right? Or versus category specific. So of course, if you have a resistor, then the properties of those resistors are what you're going to probably try to what we'll call the primary properties. We don't want to get everything, because when you start getting into a huge list of parameters, yeah, maybe you can get them all in, because during the let's say during the input process, you're putting this in a spreadsheet and you're pulling them all in. But now when a new part has to be created, someone's going to have to go in there and manually type in each and every single one of them, and that's a lot of work. And really the intention is not to grab all of these, every single parameter you can imagine for a component type. It's really to grab the primary ones so that you can make an intelligent decision about using that part in your design. And of course, enough information to create a bill of materials. And we've talked about this in prior webinars in the past if you want to see that. But that's the parameters, what parameters we want for each category. So what are the names? And the reason why the name's important is because we want to be uniform across all the categories. We don't want to have, for example, the resistors use manufacturer's name as man, and another one like capacitors using manufacturer, and the ICs are using MFG, because they're, in the end, ultimately what we're trying to do is create a bill of materials. In order for that bill of materials to come together, the names have to be common. So that's really important. And what are the values? So you see down here, let's take, like, for example, resistor formats. Which one are you going to use? There's so many different formats that you could possibly use. And then on top of that, do you even put a suffix on there as well? And these are all the things that really need to be hammered out during this stage of the library creation. In fact, here's one that we did for a customer a couple of years ago. Here are all the parameters that were found once we extracted all that information out of their libraries, and these were all of the categories that they wanted. In fact, in this company, they really wanted to keep the number of categories down to a minimum, which is fine. And so we put a check mark there if it was supposed to be for example, obviously this is capacitance for capacitors, but they also wanted it for the diodes and the LEDs as well. So this is why we put this chart together. So in summary, okay, what I just talked about today is a specification. I know that's a really bad word in engineering, but you really do need, this is a specification, and because it's a large project, it's a large undertaking. It's not something you can knock out in a weekend, unfortunately. We certainly can't do it in a weekend, but so it requires a specification. And I want to throw this story out at you. When I worked in defense from 2002 to 2007, I worked on 11 projects. I was in a test integration group, so it allowed me to touch a lot of different projects within the facility. And in retrospect, when I was thinking about it, just as I was leaving the company, I was thinking about the projects that were a lot of fun, and the ones that we call death marches. I mean, like, they're just miserable. it didn't seem like there was an end to them. And what really defined the good ones from the bad ones was the specification. When we took the time to write the specification, everything went out smooth. And I'll be honest with you, when we first do the specifications, it seemed like we were falling behind, because trying to get everybody together to meet, because everybody else is doing all their other things, trying to get them to meet on a consistent basis was not always easy. There was always arguments, which is good, because this is where you want to have those arguments at the very beginning. But in the end, when you had a specification, everyone had their marching orders. And if someone tried to veer off, then it was easy to say that's not in the specification. And if we needed to be in the specification, then we pull everybody together to rev the specification. And so the time that we took at the beginning pays off really well in the long run, because again, there's just no arguing. Whereas if you don't do the specification, you may save that time in the beginning. The problem I find always, especially with libraries, since it is a team effort, you're going to have everybody wanting to define it their way. And so then you get tons of emails, and you get tons of meetings anyways, trying to get everybody appeased. And so whether you're going to do that in an orderly fashion at the beginning, or you're going to do that in a chaotic fashion throughout this effort, that's up to you, but the specification can certainly avoid a lot of that hassle. You got to have stakeholder buy-in. This is really important with Altium products, because you know that if someone's not buying into this, what are they going to do? They're going to keep their old library, and they're going to avoid this whole thing altogether. And then you can start getting into what we call the contractor's loop, and I don't even want to talk about that part of it today. You want to just have everybody buy into it. And if you sell it right, everybody's going to agree that they want to have a central library, and everybody's going to be willing to participate, but they have to feel like they're a stakeholder, or they're not going to participate. Definition may include graphical styles. Now, if you remember at the beginning, I talked about three things. I talked about the database, I talked about the component, and I talked about the graphical styles. And I just find that ultimately you are going to have to deal with graphical styles, which are the symbols and the footprints. But here's the deal. You probably already spent a lot of time just trying to spec out the database that you're going to use and the components themselves. And the graphical styles can kind of wait towards the end, because in the end, you're going to need it anyway. And you're going to want to make sure that they're organized in such a way anyway. So that the definition of that can kind of come a little bit later on if you're really getting a little pressed for time. Let's talk about library implementation here for just a moment. So library implementation is the execution of the structure that you just spent that time defining. And what does that include, or may include? The configuration of the system database, the roles and permissions, if they happen to have that built into it, the setup of the schemes, the ID formats, the revision, the lifecycle, the folder structure, or in this case, if you're using a database, it would be a table structure. If there are templates, like L9, for example, we have templates built into our product, so that when you go into a category, the template's already there for that particular category. Of course, Concur Pro and 365 Pro have these as well. And that's it. And for these here, they will take a little bit of time. They are manual in nature, but it's kind of, if you set it up right, it's kind of fix it and forget it. And that's kind of a nice part of this. So up to this point, we have just talked about just getting the structure and the definition going. Now let's get into the nitty gritty here, because this is library restoration. And I hate to break it to you, but this is where it's going to really start getting tough. Why? These are the things we're going to talk about. You got to collect the information. You got to take all this information, merge it together. You got to analyze it to see what you got and what you can get rid of. And that's just as important. You don't always have to keep everything. The category formatting. So what you got from the definition, you start bringing that in, formulating it depending on what you think is best for you, whether it's in a table, in a database, or in an Excel sheet, or in a series of Excel files. It's up to you. Organizing by categories, so taking everything you merge together and then sorting them out into their respective categories, and then the actual component editing themselves, filling in the missing blanks, or correcting the formats so that they all look the same, and then the graphical cleanup, which again is your symbols and your footprint. So let's go into these into more detail. So the collection, what do I need to collect? Well, there are different sources out there. And so let's talk about the ones that we collect or try to collect when we engage with a customer. The first one is a database library, a DB-lib. And here's just an example of it, right? Some people say, well, what does a DB-lib even look like? Well, this is what it looks like. And if you want some more information about how they get set up, we've done webinars on that in the past. So, but this is just an example of a database, right? And just columns of information, each row is a component. And if you already got your database, you're in a really good position. Why is that? Because it contains your parametric data. right? And it also contains your symbol and footprint links. Right? It's probably functioning or somewhat functioning, or at least even if it doesn't have all the libraries and symbols, like the symbol and the footprints there, at least you know what it was called, so you could possibly go fishing for those things in other libraries. And then it's closest to what is needed for migration. So here's the thing, is that ultimately, if we don't have a database library for migration, which we think is the best way to migrate stuff, or at least in a spreadsheet, because that's what you're going to find, is that the database library works very well in that context, either for Altium products or even just other databases if you're trying to import their stuff in. This is going to be the closest that you're going to need for that actual migration. And it works out really well. In fact, I guess the point I'm trying to make here is that what you're going to see in a moment is when you don't have a database library, what are we trying to do with that data? We're trying to make it look like a database library. So this one already has the look and feel of what we're trying to accomplish here. The second source that you may have, it may not be a database library, but you've got the classic schematic libraries, PCB libraries, possibly integrated libraries. And so it looks like something like this, right? Where you've got a file and it's got a whole bunch of different things in it, like resistors and capacitors and a buzzer and a diode and so on and so forth. So it's a mixed bag of components. So there's no sorting being done here per se. It's just a bunch of components being put together. And that's okay, because you can still do things with this here, okay? But let's talk about the advantages, disadvantages. The advantages is that it does still contain parameters, symbols, and footprint links, which is really useful because in the end, you're going to have these things anyways. Likely used in design, not guaranteed to be used in a design, because someone may have started and realized later on that they don't really need this in their design, or it's not going to be practical for design. So there's a high likelihood it was used, but that doesn't mean that it was used. There are some disadvantages to this, of course. Parametric data may not be complete. This is to be expected, and parametric data format is not consistent. Certainly not consistent between parts in a library, and I can guarantee you they will not be consistent between two different libraries done by two different designers. Okay. And unfortunately, it's not in a database form, but that can be remedied. The next one is the project files. So if you don't really have libraries, fortunately in Altium, you can extract out libraries from your project files, especially if they're completed. So libraries are extractable. It looks something like this. So for example, if you go into the schematic editor of a schematic within a project, you go to design, you say make schematic library, it will make a schematic library, or better yet, if you have a completed project, say make integrated library, and it'll take everything, not only the symbols and the footprints, but they'll link them together and put it into a single integrated library, which is extremely useful. And of course, you can extract those out into their separate schematic and PCB libraries afterwards as well. So you get a lot of flexibility with that. So what are the advantages of this? You know they've been used in the design, which is great. The disadvantage, parametric data may not be complete, right? This is not uncommon, and it's certainly not in a database form. The next one after that, so what do we do when we're working with a customer who really doesn't have any libraries? In fact, we have one customer where they really don't have libraries. So what are we using? So one of the things we've asked them for is their projects so we can extract out information. But obviously, if they didn't have libraries, they don't really have a whole lot of parameters. But what they do have is bills of material. And this is another really great start place. So here's an example of a bill of materials, right? You have your typical description. They usually give you some designators, though honestly, the purchasers don't care about the designators. That's really more for the designer's purposes. The manufacturer's name and the manufacturer's part number and the quantity. And that's really all you need for most purchasers to get the job done. So what's the advantage of this? It's a definitive list of components. We know they've been used. As a matter of fact, we know they've been purchased. And so that's far better than just what we might have in a design or in a library, especially if those libraries weren't clean to begin with. The disadvantage, of course, we have no symbol or footprint data, right? We just only have a manufacturer's name, manufacturer's part number, and that's about it. And then there's missing parametric data. So we're not going to send all the parametric data, even if we had it, we're not going to send it in the bill of materials because the purchasers don't really care about it, right? I'm not going to send all the individual values or characteristic parameters of a resistor because they just need to know the manufacturer's name and the manufacturer's part number of it, okay? And when you start taking the bills of material, you're going to ultimately try to get these all together. So you're going to have to try to remove the duplicates. So there'll be a little bit of work there, but that's going to happen anyways later on, as you'll see here. So one other source that we find to be extremely useful that customers have provided us are server data dumps. And what do we mean by that? Well, primarily purchasing data dumps, but sometimes there are other collections of components that are being kept within certain organizations. So if they can provide those to you, they're extremely useful. So something that looks like this, and I purposely took this is one from, that I took a snapshot of one, and I purposely did cable cords over here, because this is what you're going to expect with this. They're going to do these data dumps, but a lot of times these data dumps are not done by engineers, they're done by somebody in the financial department or the purchasing department. It could even be done by a program manager who, yeah, okay, they're in the engineering area, but they really don't understand what you need. So they're going to do a very large data dump of things, and you're going to get anything and everything, including stuff that you really don't need. So there's going to be a lot of thinning out that you're going to have to do. So as a matter of fact, well, let's just talk about these, and then I'll give you a little story of one. So the advantage is that they contain parts and used in all designs. So you're not taking bills of materials and trying to copy and paste them all into one file. You have one single list. You also get the company part with it, part number 2, which is really useful. Let me talk about some of the disadvantages of this. There's no similar footprint data, so you're gonna have to add that in. There's missing parametric data, which again, because it probably came from bills of material, and you're gonna have to weed out a lot of non-electronic parts. So that example that you saw there was a cable, right? And so that you probably don't need to have a cable as a part of your PCB assembly. And so there's gonna be a lot of these things that look electronic, but they're not necessarily electronic, and you're gonna have to just delete those out. But before I go, just give you an example of this. We did have a customer about a year ago, and they had this type of data dump here, and they did have some libraries with it too, but they had about 14,000 parts in that particular list. And they were in kind of a rush to get things done. They said, we don't want to recreate parts. We'll create those later on if we really need them. What we want you to do is go through, and if you can find the company part number, the manufacturer's name, the manufacturer's part number, so those 3 things, and then if you either can find the symbol in our libraries, or you can create a viable symbol, like if it was a resistor, okay, fine, you know what that's going to be. If it was no 402, fine, use the 0402 footprint. But you got to find a viable symbol and footprint, either through the libraries or just by the fact that you were going to have many of them that had the same type of symbol and footprint. So those are the 5 criteria. And so we're able to go through that and basically extract out probably out of the 14,000, 4,000, a little less than 4,000 components for them in order to continue with their library. So that just gives you an idea of what we can do with the server data dumps. In this case, we had to lean on it very heavily to make it work. So what do you do with all this? You collected all these things, and you can have a lot of different things being thrown at you. But ultimately, what you're going to have to do now is something called a data merge. So what is this? This is establishing a single coherent data set. Now, we call it data set for a real reason, because that could be done in an Excel sheet. It could even be done in a database, right? It could even be done in a file, or maybe you just have some textual thing and you're running a code through it. You know, call it what you want, but this data has to be in one single area so that you can look at it as a whole. That's the way we try to do it here, just because it's the only way we can really get ourselves wrapped around what we've got. What this is not at this stage is you're not component organizing. In fact, we're taking everything and putting it together, regardless of what it is. And we're also not doing any component editing at this point. We just want to know what we've got, because on the higher level, we just want to see if we even want this component to begin with. Okay? One of the recommendations that we make, as I said, we call it a data set, but we always recommend the use of Excel for this. And why is that? Because there's no restraint on the work environment. Excel is Excel. If you try to do this in the PLM, now you're going to constantly fight revision control. You're going to rapidly bloat the system. You're constantly making changes to it. So you wouldn't want to do it in the PLM. Even in the Altium environment, if you're just doing SCH lib and PCB lib, and you work in what they call the parts manager, you can do that, but you're going to be restrained because it's not Excel, and so there's a lot of things that you're going to have to do a lot more clicking, and you're not going to have as much filtering and sorting that you have with Excel. The cool part about Excel is Excel doesn't really care what you've given it. All it knows is that you've got rows and columns, and you've got things in cells, and you can manipulate those to your heart's content. And that's a really great environment to work in. And the other thing too is that pretty much all products that I've mentioned earlier today can pretty much import an Excel sheet. You might have to format it a certain way, but in the end, Excel is just the way to go. I've always found in almost the 30 years I've been in engineering, I can't believe it's been that long, but I can tell you that Excel from day one has almost always been a bridging product in the engineering environment to get you from one tool into the next, because these tools don't talk to each other, right? And so you get Excel to take that data and manipulate it in such a way that you can export it from one and import it to another. And that's exactly what you're seeing here right now. So that's our recommendation, use Excel. So in terms of data merging, give you a couple of hints or recommendations. If the libraries exist, like you have SCH lib, PCB lib, there you have two options. So here's the first one for you. Pull all the components together in the SCH lib, or as much as you can. Now, if you really are dealing with a huge library, you may want to break it up into a few categories, like at least maybe I'll put all my discretes in one, I'll put all my ICs in another, for example. That may help, but you really do want to keep it as one because it's just going to make it a little easier for you to work in. And you're not constantly going to one, making a change, going to another, making a change. That just gets kind of tedious. So pull them all together in SCH lib, use the parameter manager for sorting and cleanup, and then copy and paste it into Excel. What do we mean by that? Here's an example of something I pulled from a parts manager. And what you're going to see is you're going to see a lot of these columns. And so as long as one of these components has this characteristic, it's going to show up. And the question to you is, do I even need that? Is it extraneous or not? And that's going to be for you to decide. But this is an opportunity for you to get to jettison a couple of these columns that you may not need during this period of time. Again, we're not doing component cleanup. What we're really doing here is just prepping this so that we can get it into Excel. The other option that you have, and I had forgotten about this, but this has been in Altium really for well over a decade. You can create a database from integrated libraries. Okay, so this is the second one. What I showed up over here is that if you open up a new DB lib and you go to tools, you go to import integrated libraries, so it has to be an integrated library, then you can go through the motions of turning it into a database form. It's going to put it in Microsoft Access, so you're going to have access in order to open it, but you can certainly work from that as well. So you'd pull all the components again together in the SDH lib, use a parameter manager for sorting and cleanup, so pretty much the same way before, but now you go create the integrated library, and that's by doing what I just mentioned, open a new DB lib, tools, import, and then ultimately when it's done creating it, you can continue to work in Access, or you can paste it into Excel. And again, I think you might find it easier to just take what's from Access and put in Excel, because Access is a database and it's trying to protect that data. That's what I find with most databases. So it's not going to be as fluid as Excel and trying to make, let's say, bulk or gross changes to your information. Now, if the libraries are too unstable, and we've come across this here at 9.connect, what we mean is just like you just can't rely on them. There's nothing you can salvage from them. Then you can merge a bill of materials together, use the company server data dumper, both, and then import them into Excel, and that's where you're going to start from there. So now that I've got all this stuff into a single file, most likely Excel, now what are we going to do with it? Well, now we got to do the data analysis and basically what are we keeping, what are we tossing? So going back to that example I gave you with that customer, we had 14,000 parts, we narrowed it down to 4,000. This is exactly the point in which we did that. This is the part identification, like can we identify things that we are not going to spend a ton of time trying to salvage out of this? Meaning like, hey, does this line item already have a company part number? Does it already have a manufacturer's part number? Just these two things alone are huge. If we can do that, then we can probably salvage the part, because finding the manufacturer's name will fall into place. A lot of this stuff we'll probably have to find, but at least I'm not having to go dig for this stuff manually to get it. And then assigning ultimately the types and categories, not sorting them, but in the sense that what we normally do is we'll create another column in this master list and go through them and say, okay, this is a resistor, this is a capacitor, this is a diode. And the reason we do that is because then later on we can resort based on that column. And then the next two steps is about getting it into its appropriate table or into its appropriate file. But that's what we do over there. What are we trying to fix during this point in time? Again, we're not trying to clean up the components just yet. We want to get rid of duplicates, and there's a good chance of that being in there. Missing extraneous values. So if you see some really weird parameter that it's like, I don't know why we've got this, that's the time to get rid of it. And then also determining missing links. Do you have, can you justify this part because you want to get a symbol and a footprint for it, right? Or is it just time to jettison this one? Because keep in mind, if you lose that part, it's not the end of the world. At just later point in time, you just have to create it and add it in when the need arises for it. Okay. So some examples of doing is like, do I need this? Like this was insertion loss. Okay, is that something that's important to you? And it could be. right? But these are the questions that you're going to have to ask yourself because it's the only one that has insertion loss. Now, again, this may also be the only part that cares about, or component that cares about that. But also the vendor. So why are we missing a vendor over here? Was this an embedded part for some reason? They call it test point, but they actually have a manufacturer number to it. So those are the kind of things that you're going to want to scout out for. And this just gives you just two of many different examples of things to kind of weed out. Then this can be actually done in parallel to what we were just talking about. You need a format by category by applying the library definition. Right, so earlier on, you figured out what the categories were and the parameters for each one of them. Ultimately, you've got to set that up. Again, if that being set up, is that being set up in a table, in some database, or are you going to set this up in individual Excel files, which is what we do? It doesn't matter, but this does have to be set up. So you standardize parameter names, and then also your data formatting here too. And I won't go into all of these things, but just gives you some example of that. And jump over here, just some examples of things like, do you want special characters, which we really try to avoid because people will leave them out or they're going to do it a different way, so the sort's not going to work well. And you can see even here, the special character seems to conflict with 0%. So that's why there's a question mark over there. But also, this is the opportunity so that if you have your definition list, but you've also been going through your components, maybe there was different names that were given to them, so do they match up? Or are they even there to begin with? Because maybe you said like, look, we really ought to have this parameter, but it was never introduced to the components that you already had. So now you're bringing it in and nudging out to fill in those blanks. Or are they just different names, right? So I remember this conversation with the customer. We originally said the definition list needed energy, and then later on they realized we don't want to put the unit in there. So we'll put the unit up here on top and then just make sure we just have a flat number so we can sort on it, which made sense. From there, we are now going to take the components and move them into their respective categories. So here you can see that this was a basically it was a spreadsheet, and so there was one for capacitors, one for diodes, and so on and so forth. They had a few extra things in here as well, but the fact is that you can see that now it's starting to formulate based off of the categories. Okay. And how do we do that? As I mentioned earlier on, one of the first things we'll do is when we get the master list together, we create a new category and then try to make sure we associate that to a category that's been defined by the customer. And then now we finally get into the cleanup by category, reforming the values to the standard, adding missing data, standardizing the description. The standardizing the description to us is important. It's based usually on the component parameters you already have. And so here's an example of it right here. This is a really good example of a description that you can read. What did it say? Well, the prefix here is cap. So you know it's capacitor, what type of capacitor in terms of its material, the value of it, the voltage rating of it. Well, this is ceramic, but this is also, I think, another material aspect of it. And then, of course, the footprint of it as well. And if they even had a percentage, like its tolerance. So it's very consistent, which makes it easy for sorting and to look at as well. And then even their library references, I thought they did a really solid job with this as well. So I just I basically squared it off, not circled it, but squared it off just to kind of give that example. I was also humored by the fact that their footprints were not necessarily following standard, but really the key thing is the description, because this is what's going to end up in the bill of materials, or just having a constant format. Even the voltage here is constant. There's no V's in here, no volts in here. It's very, very consistent, which is a good thing. So the last thing that you got to do over here is the graphical cleanup. And what I'm going to recommend is you avoid something called SAM, which is successive approximation model. What does this mean? Well, now you start going into these SCH libs and you start cleaning them up. And let's say about 10 parts down, you realized, oh, you know what? The rectangle that we use over here, some of them are transparent, some of them are not transparent. And then now you got to go back and make sure that all of those are transparent. So and of course, if you don't do that, by the time you get through everything, then what you have starting at the beginning, what you have at the end are going to be very different, because you're adding more rules or making more judgments as you're going along that weren't applied to the original components. That's the successive approximation model, and you want to kind of avoid this. This is where now you want to start defining things. We said earlier, if you didn't do it up front, you're going to want to start doing it now. This usually becomes what I'd call a style guide. So you start keeping a list of those things that you expect out of your symbols. And so and even the footprints as well. And then here's also where you're going to start optimizing and removing duplicates. So if you're familiar with obviously symbol centric. If you've made 1,000 resistors in your symbol libraries, your original symbol libraries, they all have their own graphic to it. You don't do that in database libraries. You only need one copy of it. So a lot of these symbols that you might have in some library, you might just have to just delete because, quite frankly, you'd only need one copy of it. And it's no longer the symbol itself defining the component. It's just now, just be blunt, it's a dumb graphic, like the footprint. It doesn't define the symbol. It does not define the component. The component now defines itself, especially in a database library. It's just pointing to the symbol or a symbolic reference. So what do you do with it? Let's talk about symbols. Naming. So if you're going to go in and clean up things, what are the two things you ought to clean up? Naming conventions. And the reason you want to clean up naming conventions, especially if you use Concord Pro or a database or just an Altium product or some type of database, is because you want them to be people to find these again, to reuse them again, right? So this connector over here is not a specific connector. This one over, actually, this is a bad example. Let's go with this one here. I don't know how you can have a stagger when it's one row. But let's take this one over here. So if there was a 2x1 connector here, this one could be used again for all connectors that happen to have a 2x1, right? The component defines it. This is just a symbol for it. The second thing over here is being consistent with the graphic itself. So this was done by a colleague of ours, and I'm going to be perfectly honest with you. I wouldn't have done it this way, and that's fine. So I'll go with it because they liked it, and this is something they've done in prior companies. Here's the thing, though. All my connectors ought to look like this. And so there has to be a consistency. So again, the style guide is going to be important here. So the look and feel, the colors, the lines, the fonts, those are the things that you're going to want to address as you're trying to get these symbols cleaned up. And then the other thing too, you're going to come across things like this, right? The orientations are different. The point on the grid is different. The size of these things could be different. Some could be 300 mils, some of them could be 400 mils. This is where you're going to have to talk to your colleagues and determine what's the best approach to this. Okay? And this is where a lot of fights tend to happen, especially if you didn't ask them. If you work with them and then you have your discussions, there are compromises to this, like alternative parts which you can do within the file itself. But this is stuff that you're going to have to resolve. And you're going to find a lot of these examples. Everybody's drawn it a different way, but you only need one version of it. So what's the agreement? So also footprints, I didn't put it here, but naming convention is really important. And by the way, I would encourage everybody to use the IPC naming convention. You can find it on the web. They don't charge you for it, which is kind of rare for them. Normally they charge for their standards, but the footprint standards are available on the web free of charge. And the only reason I'd recommend you do this is because they've thought of everything. And what I found is that when you try to do your own naming convention, you'll ultimately find yourself getting stuck somewhere because you can't differentiate two different footprints from each other because of the limitations of your naming convention. So use the one from the IEEE if you can. And by the way, if you use the wizard in Altium, it always uses the IPC wizard anyways when it creates the part. So layer definitions are really important. This is something that needs to be definitely declared and figured out before you move on. If you're interested in it, we did a webinar on this recently. This is one that comes from our website. We have a website that shows a recommendation, and it is based off of what I'll call the unofficial layers that Altium uses all the time for their mechanical layers, like mechanical 13 has traditionally been used for 3D top, for example. And of course, dimensions. What dimensions are you going to use? Are you going to use the IPC dimensions? You're going to use the manufacturer's dimensions? And in some cases for the client, I've seen this now twice, where they are doing special things with their components. One customer is doing encapsulation because it has to be ruggedized. And as a result of that, they have found the manufacturer's recommendation will not work for them. And so they've done their experiments and they have said, no, we've got to build them in this particular fashion. They've got to find their way into our libraries. So dimensions are going to be important as well. And iterate this. It's not going to be totally linear. And you probably see that if you're thinking about this through your head, you know that there's going to be things you're going to do. You're going to have to go back and revisit it. So understand what's found versus what is needed, implementation of your feedback, and lather, rinse, and repeat. Because you know that you just got to find some humor in all of this that needs to be done, because there's a lot of work, as you can see here. And then lastly, the migration. So up to this point, all we've been doing is trying to put together a solid Excel sheet that looks like a database library, but we haven't actually made it in, we haven't got it to its destination yet. And migration does require a few things. Number one, some type of spreadsheet or an Altium Designer, if you have it in a Excel and treat it as a database library. That works really well for migration. Symbol files, so your symbol files use symbol footprints. The fact is, and let's just make it clear, all three of these have to be ready to go and they're already done. You don't want to do any post cleanup later on, because you start doing that and you're going to start bloating your database. Right? So let's say you had a resistor and like, for now I'll just throw this resistor in there, and then later on I want to clean that up. Well, let's say you had 1,000 resistors that you migrated in something like Concord Pro. If you made a change to that resistor, we will bump the rev on the resistor, and you'll now bump the rev on 1,000 of your components as well. And so, it's going to literally double the size of your database overnight, just in terms of what it has to store. So, what do you have to do over here? Well, connecting to the target database, knowing what it wants. And again, you may be going into Oracle or Arena or something else. So know what they want in order for it to be brought in. Migration per category table. This is a big recommendation of ours, especially when you're doing Altium Designer, Concord Pro or Altium 365, because it gives you a lot more control and it makes sure things end up in the right folders with the right templates, with the right, basically with the right version control and all the other things that go along with it. And after you do it, you review, fix, and redo. It's iterative based on containers, project phase, library size, client need, and this just happens. And by the way, we've gotten tangled up on this too. We had a customer, it should have been a no-brainer thing. They already had a Microsoft access. It should have been easy for us to push this one in. We spent over a month. Why is that? Because come to find out, they had special characters in that access database, and the migration tool was crashing on it. We were trying to get it into 365. These things happen, right? And most of these things are just tedious. There's no real automated way to do it. You've got to go through it, set it up, and then just get it to read through each of the categories, and you just do one at a time. So it's doable, but unfortunately, hopefully it'll be just done once, but it's not trivial. It can be tedious. So with all that being said, there you go. That's how to get this into a library, how to restore it. And in a nutshell, for the amount of time that I have here, but I do have a polling question for you. Now that you've seen this, are you ready to tackle your own libraries? Are you happy with the library that you have? Are you going to seek help outside, or are you just going to run for the hills? All right. Okay, so half of you are going to tackle it on your own. You have my blessing, and I wish you all the best in that. And of course, feel free to take a look at the resources that we have on our website for that as you're going along. As you can see here, I only had an hour to give you an overview of what you're going to need to do, but at least you now have a path to follow for that. For those who are very happy with the libraries you got, basically a quarter of you do, that's great. I'm really glad that you are happy with those libraries, and do everything you can to maintain them so that you don't ever have to get to this point. For those who are seeking outside help, we're here for you, and we're going to talk a little bit more about us here in just a moment. For the 20% who are just running for the hills, I'd still encourage you to talk to us about it, because we might be able to point you in the right direction. Here at 9.connects, we want to make sure that you're successful, and that doesn't necessarily mean an engagement, because we know that customers have different financial circumstances and whatnot. But at least we can point you to the right place if you need additional help. So with that being said, I'd like to talk a few minutes about 9.connects here and what we provide. Let's talk specifically about the library services that we provide here. Well, number one, we know your pain, because everybody wants it, but nobody wants to take responsibility for it, which we get. Meeting to define the library is quite like herding cats, right? Because everybody's got other things they want to do. Everybody has their own ideas of how this is going to work. And so it's not always easy to get everybody together first and foremost, and then get them to even agree on things. Data collection is arduous. We know it is, because a lot of times when we work with customers, we've got to collect whatever we can from people outside of the design team. And so we've got to just get all that information. You've got to go digging a bit. Merging the data is tedious. You just saw 20 minutes worth of me explaining how we merge that data together. It's very tedious. And then there is faith in the data, like what you already have. Can you run with it? And just because you're reformatting it, is it still correct data? And that's always a concern, right? The integrity of the data. And of course, dealing with the migration issue. Sometimes it goes as smooth as silk. And as I said with one customer, there was a month of working with Altium to figure out why we couldn't migrate these things in. Here at 9.connects, we certainly have the experience. We've assisted numerous clients over the years, from large tech to small businesses. And when I mean large tech, by the way, I'm talking about companies that you hear about in the news every single day. Okay? They do come to us as well, because even though they may be large and they have a lot of money, their design teams are not necessarily given more resources. So they need our help just as much as the small businesses do. And then hopefully you will do this only once, but we've done it many times, right? So because we've done it many times, we know the pitfalls, and we certainly know the limitations that you can and cannot do with certain products. And we have the tools, proprietary scripts and code. Fortunately, it's not a push button solution. Every company is unique. So when we work with customers, we use these scripts and codes to help expedite some of the process. Some of it is still manual, but some of it we can help expedite through these scripts and codes that we have developed here at 9.connects. And the big thing is we drive the effort too. That's one of the big problems that people have, is like, hey, this is huge, right? If you think about it, it's just a huge effort to put on someone's shoulder, especially if they're not a program manager or they don't have the, management wherewithal to do it. So we're the ones who will drive it for you. And just think of this for a moment. If you try to do this by yourself, and we did a webinar on this earlier, 1,000 parts at 40 hours a week will probably take you about 11 weeks on your own. And that's assuming they'll just let you do this 40 hours a week. And if you break it up to 10 hours a week, that's pretty much a 1-year effort. And by the way, this doesn't include the library definition or setup. So this would be all the effort on your own just to try to get this to work forward. So what we can do is, we can somewhat expedite this. I can't give you a specific amount of time in weeks or months, only because every customer is different, but we certainly will get you to the end point in probably a faster point than what it would take for you to do it on your own. And then we are dedicated to your success. Now, what do we mean by that, right? Because that's just a broad term. Everybody says we're dedicated to your success. Facilitate the meetings to define the libraries, mediate between stakeholders, because a lot of times there's arguments because people want certain things. They don't realize how difficult it is, or whether it's even viable, or if it's even necessary, right? For some, it might be necessary for someone, but not really necessary for the other teams. So we're able to explain that to people to try to make sure that everybody's on the same page. Assist with the configuration of the library container, whatever that may be, right? Whether it's Concord Pro 365, not L9, whatever the product is, that we can help with that configuration. The drive the effort to collect the data. We're the ones who can send out the emails, constantly harping on people to provide stuff so that we can get it. We'll mentor those who will be the administrators. So what we don't do is do like a 3-day training saying like, here's Concord Pro. These are all the things you need to know, best wishes. We really don't do that. Because it's one thing to sit and learn the features of the tool, it's another thing to actually see the day-to-day operation. Normally the people that we work with, there's a group of people that are assigned to this, and we work with them, and as we're going along, they see very quickly what we're doing and how we're doing it, and so they just learn over time. That's how we basically train the administrators, is just through our interactions with them. Process the data into a viable data set for migration, so we've become efficient at this. To process that data, where a lot of the stuff you probably saw is like, man, that's going to take a lot of effort. And without some of the scripts and the coding that we've set up to do that, this is a very manual effort. Validate, and this is another big one too, is that we can validate your data against a source of truth. So this is what I call a value-added feature that you probably wouldn't be able to do in the time that you had to do it in. Migrate your data into your library, and the big thing is to train your users as well. And the last thing is that we can be your library administrator. So a lot of customers come to us now. Why is that? Because number one, getting a rec for a dedicated librarian is really hard. And even if your company does allow you a rec to hire a dedicated library, good luck finding that library or component engineer. Because quite frankly, ever since the tech wreck, and especially after the 2008 Great Recession, pretty much every company has wiped out their librarian or their librarian staff. And so as a result, there's very few people who are trained in this now. So this is what we do. So can we be it? We certainly do. And for a lot of our customers, they say, look, take our libraries, run with it, and now support us after we're done putting it together. And the same thing with the component creation. If we do work with you, we can certainly create the components to your standards. So it's going to look like your symbols. It's going to look like your footprints. It's going to match up with those, same look and feel. So there's one thing I'll put over here. I've made reference to a number of our other webinars that we've talked about, because we've done this over the last couple of years. We'll put this in when we release the recording. We'll also put this down below in the description of that recording so that you can make references to that. So with that, thank you again for attending today. We hope to see you at our next webinar in May. And so stay tuned for that.